Right. So, good evening, everyone. So, here we have a panel uh, to discuss about who's a pragmatic programmer is. Right. So, can you guys tell me who's a pragmatic programmer? Sorry, but we want to get a sense of it. What do you think about being a pragmatic programmer? Any volunteers? Right. So being in simple form, being sensible and being realistic is called means pragmatic. So pragmatic programmer means you being simplistic and realistic about your programming, right? Uh, so our discussion is mainly based on the experience plus a very well-known book called The Pragmatic Programmer. Here I have three distinguished programmers in my panel. So I hope they are still like to being called as programmers, right? Right. So you can see why how simple they are, right? So some are directors, some are architects. So that's being all about pragmatic programmer. So without wasting much time, we'll go into questions that I have for them, and also there's a lot of concepts in learnings for you to get from the book. So don't limit from our panel discussion. Go read the book. They released their second edition last 15th of September. So read the latest book, right? So let's start with Udara. Udara, as a software developer, to which extent should we assume responsibility for the software that we develop?
Yeah. Thanks, Lahiru. So, first of all, I need to say, as developers, there are a lot of newcomers in Cisco labs right now, right? So, we develop software sometimes from scratch, sometimes we inherit some software from other vendors, right? We have examples are like from BD Studio. There we have some someone else developed a software and we taken over them. So the real thing is like you might be working on a single component of that particular product, right? And you will think, okay, I'm just owning that particular component only. That is not the correct way, right? You are responsible for the whole product. That is the key thing you have to think and you have to take into your heart. Not only the component you are developing, it's all about the product. So if you see something, okay, some issues in the code related to the total product, right, when you are developing or when you are doing integrations with other components, when you are doing the development, you should be able to raise those, right? Saying, okay, there's an issue in this component as well, so we need to fix it because the whole product is the one you should be accountable, not only the one you are developing, right? So that is one critical thing you have to take into your mind.
Thanks, Udara. Anything to add, Hasitha?
No, I think he summed that up.
Thanks. So let's move on to the second question. I will give it to you, Hasitha. So if you find any terrible code or a design in one of your projects, right? What do you think? How regularly we should revisit them? How often?
Okay. When you say a terrible code in my project, if I put on the developer hat, is it a component that I have inherited or entire?
Anything.
Okay, so I'll answer first for the component owner. And that's where I want to start basically. There's need to be something called a component owner because what I have seen in the past is that we have this concept of feature teams where we come in, drop a little bit of code into each component to build our feature and then we move off. And then another bunch comes in, drop some code and they walk off. But nobody actually owns the component. But if you have the concept of a component owner, then you are responsible for the long-term health of that code base, in addition to delivering the features. So in that case, it's entirely up to you to make sure if you have to revisit to fix something that you have seen in the code, it's up to you. Especially if it's a ticking time bomb that's going to explode sometime in the future. It's your responsibility to say, look, I can't be responsible for this. I have to fix it. I don't know whether that answers your question. So that's my stance. Anybody?
Anything?
No? Okay.
Yeah, I'll put my 2 cents into it. If I am the code owner, as Hasit said, so for me, if there's something terrible in my code, I feel I won't be able to sleep basically, right? So I would, as soon as I find it, I'll try to fix it. But given the business deadlines or whatever things, right? So I would normally educate my senior. If when I was a junior, then I would like sort of try to refactor it.
That's another small thing. So you should not be saying, oh, this was written before my time. You can do that in the first 3 or 4 months when you inherit something. But after about 6, 7 months, you don't get to keep blaming the previous developer. You need to take ownership at some point. So I know this because I'm going through this right now.
Yeah, so I mean, as a junior developer, something which is handed down to you, you can look at it as an opportunity to grow, because then you can be an expert on it and you'll be a more valuable person to the team. And like, at least in the past, like for people like that, when it comes to reviews, like we've looked at them positively on that. So that's a good thing to do, I think, generally. Yeah.
Yeah, I think it went really well, I think. Okay, let's hope for the same for the other questions as well. Right. So these are like little bit tricky, like not really programming. If anybody came to listen some tech talk, would be disheartened by now. But I think this knowledge will not only help you, but the overall team and the company as well. Yep. Sure. Ask us. Yeah.
That's a bit of a curveball. Is it even possible to modularize it to a level where you can say in the same code base, some person owns this module, is that possible? So I get what you mean. Different people have to touch different modules to build a feature. So we are doing something like this right now. The component owner, any pull request coming into a component, even if other people are developing it, it needs to go through the review of the component owner, because he's ultimately responsible, and he gets involved in the designs, and he will say this design is fine. He'll give his input. The other team will go and develop, and once the code comes back, it needs to pass through his gate. I don't know whether that works for you, but that's something that we're trying out. But ultimately, the long-term thing is to slice up the code into smaller components. So that's a specific question, no? I personally believe that any code base can theoretically be split up. Only problem is when you do that, the interactions between the different components become more expensive. So I think we can have an offline chat. There are certain things that we are also doing. We also have a very giant Redux application, but we managed to slice it up into smaller mini single page applications.
Right. So it's again our third question is about refactoring. So I don't think we should touch on that, since it's more or less about how to break your code, like refactoring. So I will tell like basically we want to discuss like how now if you have written a code, right? I know that if I were the developer, if I look at the same code tomorrow, I feel that there is some improvement, right? So my question to the panel was actually how frequent you should go and revisit your code, rather than just write it and close the chapter and never look back again, right? It might not be part of your delivery, right? So what do you think about that?
Anybody?
Shall I? Yeah. So one main thing. So when you think about revisiting the code, so think about this. Like we have this AS400 solutions, SaaS solutions, which is running right now in Cisco, right? Which is running 100% smoothly, right? But the only difference is the technology-wise, it's pretty much outdated, right? Do I need to revisit that code? Okay, it's running really well. No, right? We don't need to do that. That's my opinion. Someone else will have a different opinion. That's my opinion. But now you are developing a new one. You are, I would say, rewriting that some kind of a module on the SaaS, you are rewriting it, right? Now you are in the implementation process. So what in your pods and everywhere, you have peer reviews and different review processes, right? You should have did a particular implementation in a certain manner. When you are doing a review, you suddenly see someone else has done that in a, I would say, more efficient manner, right? So in that case, okay, you see, okay, I have done this in this manner, but this guy has done in a more effective manner, right? You can revisit your code and check, okay, whether I can have that same kind of a implementation in my code as well. So those are the improvements you can get, right? When we are doing, we can clearly see those things are happening right now when you are doing peer reviews and everything, right? So I would say the practice is like if it is implementation is going on, so you should revisit very often, right? And think how you can improve your code. That is my opinion. Anything to add?
So even in the AS400 kind scenario, now software doesn't decay like other machinery. No, if you write the code, it works. But the problem is the world around that software moves forward. Let's say you are running on a certain version of Ubuntu. Your code works fine, no problems. But eventually the Ubuntu version moves forward and there are certain critical bug security fixes you need to get, you need to upgrade. In order, when you upgrade, your program becomes not backwards compatible. So software decays in that sense, just gets left behind. So AS400 also, it might work perfectly, but one day they decide to discontinue that series of servers, you are in trouble. So I also agree with him for a different reason. I think we need to keep coming back to the code regularly. The other reason is there's this effect where you write a piece of code, 6 months later you come back and look at it and it looks like it was written by somebody else because your mindset has changed. So then you've gone forward, then it's a good time to look at your mistakes and correct them.
Yeah. So detecting that your code needs an improvement is one point, but so in most cases when we detect that, we might not be able to do a change right then and there because the other guy is working and we can't check in something like that. But usually what at least I've done once or twice at least is like noted that down, and when I have to touch that area again, I refactor it then, because then there's a pull request, a proper process ticket to go through, things like that. So that can be done just yeah.
Can I ask a different question to that? So that additional pull request, not trying to put you on the spot, but this new pull request is targeted towards a certain feature. Absolutely. So the product owner wants that feature and that feature only. He wants to control the scope. Yeah. How would he feel about us piggybacking some technical improvements along with that feature?
So at least the projects that I worked at, the guys who reviewed the code, they were okay with it and we encouraged it. So it has to be taken at a certain level of engineering. There needs to be a lead who takes that responsibility in saying to the product owners, yeah, we are going to improve our code in certain areas which might not affect this individual feature, but we are taking that risk because we know to evolve the code. That if something goes wrong, that comes down to the approval of the code review and the guide. Yeah, of course it does, but you have to take that.
Yeah, I think it nicely boils into my next question. It's again for Hasitha, right? So, why is proper communication important to explain the good things that a developer has done, right? Even the example you took, refactoring, how do you communicate it like effectively to win your product owner, right? It might have some other advantages. So how do you communicate such things?
Actually, before that, let me touch on communications within the engineering organization from you to your managers, because I don't know whether you have heard of this concept of a dark matter developer. Dark matter, you know dark matter, right? That they're exerting influence, but nobody sees them. So there are developers, very good. I've seen them. Does their work exemplary, but they don't talk much. So unless somebody goes and looks at their code and really digs in, they sometimes get left behind while the talkers tend to come up. There was this thing that happened to me. I'm not saying this is me, which part is me or where this happened. There was a certain project where one developer was doing a certain component, another developer was doing a certain component. First component, he did 100% unit test, worked so perfectly, it went into production, client was happy, no problems. Nobody talked about it. This other component, from day one, problems, 6 months. In all the client engineering meetings, he's talked about it. 6 months later, this guy fixed the problems that he created. Suddenly, he was a hero. So the guy who did it up front the first time, so that's why it's important to communicate. Look, I did this. I wrote something of this much complexity in this much time. Here's my defect density. Here's how much resources this thing is using to do this many transactions per second. You need to communicate that. And to do that, you have to do it in a way that non-technical people understand. You have to arrange it in such a way that if you give him the full blast of technical information, they're going to tune out, especially the non-engineers will tune out. So coming back to your question about POs, product owners, no point telling them technical reasons. You need to tell them what benefit they are getting, or another better way to do is to tell what could go wrong in the future if you don't do it. So if you want to do an Ubuntu upgrade, what you can tell is, if you don't do it, sometime down the line, somebody is going to come through our network, exploit that, and they are going to get a dump of our user database with all the password hashes, and we are going to be in a big problem. So you have to create those scenarios and show them, here's how much dollar value you will use, stuff like that. Or you upgrade into a more efficient tech stack, you can say, this is how much you'll save from your AWS costs. And again, to do that, you need to improve your skills.
So for that, I would say the lead plays a major role. Like so right now we face the same thing, right? So there are people who are developing, like doing real good stuff, but they don't talk, right? So as a lead, you should be able to highlight these people, and make them communicate, right? So give them the credit and make sure that convey that message to the PO and the other people as well, saying, okay, this guy is really good. Then suddenly that guy will start to communicate and do the necessary stuff. So I would say that's a real important thing as a lead to do.
So let's finish off all the developer stuff. I'll just move on to testing, right? Testing a piece of software. So how much of the testing responsibility lies with the developer? The question goes to Hasitha again. Yeah.
How much of the testing responsibility rests on the developer as opposed to quality engineering? Okay. Different people have different stances. Yeah, I'll tell you what my stance is. My stance is that you should never commit a line of code which you have not executed yourself, at least once. I don't know whether it's unit testing or whatever, but if you have written something and you are not entirely sure about its behavior, how can you put it out into the world? The way I look at it is QE doesn't produce quality. They assure quality. You produce the quality, they need to act as a sort of a safety net. So you need to, as a developer, when you commit something, make sure that you have run it at least once, every line of code. That's actually my stance.
So one thing I want to talk about is this. So when you're adding unit tests, for instance, so it's very difficult to later go into a piece of production code and add unit tests without changing it, because you need to, for unit tests, you need to do dependent injection. And so the code structure actually depends on the fact that there are unit tests when you check it in. So like if you are going in a unit test approach, then it's important to at least have some unit tests at the time that you check in. It might not be 100% coverage, it might not be 100% state coverage, but it's important such that the code that you check in, the class structure at least, is unit testable when you check in. So that's, I think, that's an important point.
Right. So we talked about unit testing and developer. So let's go a little bit on the process side, right? So to cover all the areas, right? So when you are working day to day, you might have come across situations that you were asked to find or distinguish between a tech debt, a bug, and an enhancement. Udara, can you just explain us how we can distinguish between these three?
That's right. So first I will explain what is a tech debt. So tech debt is something we incur by choice. So I'll give you example. So right now I'm working on two products, which is pretty much done by a third party for Cisco, right? And they failed multiple times going to production, right? Then they thought, okay, it should go to Cisco Labs, and we took it over. Now both are in production. So why that particular applications fail to go to production? Mainly due to tech debts. So what are those? One major stuff like those are like, let's say those are service providers, the people who did that projects earlier. So they will say, hey, we will build this product within 6 months to make sure that is MVP ready, right? So when they promise that, some of the technical stuff or some of the main engineering aspects will be pretty much trade-off. Examples like they don't consider about 100% database schema normalizations or anything. They don't consider about caching or anything, right? They don't think about the performance. It's just a MVP release which might work with few. So in our example, they did a release which is pretty much capable of handling 2 opcos. I don't know whether you guys know the concept of opco, but since you guys are now here for a long time, I would say, yeah, opcos, 2 opcos, right? But in the long run, you can't survive with that particular product, right? So there are design issues, there are, I would say, architectural issues, plus process issues related to those tech debts, right? So hope you guys understood what is tech debt, right? Those are like you can survive it with it, but not in a long term. Short term you can, long term definitely things going to be really bad. So that is what has happened, right? Bug, yeah, you should not have bugs in your product, right? So those things definitely you have to fix, especially high critical bugs, yeah, you should not have, right? So that is main thing. Enhancements, I would say, okay, those are like, my opinions, those are like, okay, CRs, like a PO or a business will ask, okay, let's do this particular change in this feature, those kind of stuff. So tech debt, bug, and enhancements, those are the, I would say, three different areas we will have day to day in our software development, right? So related to tech debt, the way we should handle it is pretty much different. So the product I worked on, like we first, when we got the, what do you call this project to us, we did a detailed analysis. Okay, what are the tech debts we have? So design wise we had issues, schema wise we had issues, all the areas we had issues. So then we thought of, okay, what are the things we can rectify very quickly, right? So then we move on to like that. So tech debt, definitely it's a long running process. Bugs, it's, you have to fix them as soon as possible.
Any other thoughts?
My view of this is probably old-fashioned, but I'll say it anyway. Where I come from, a bug is something that is in your spec, what you have agreed to provide in terms of requirements, and it hasn't come out the way it was expected. Basically, disparity between what you have built and what you asked to build. That's a bug. To me, a tech debt is a future bug. Like you've chosen, like the example we discussed one day was, you chose a database based on current number of users because you need to build it fast. Maybe a NoSQL database. But if you know that your user numbers are going to increase in the future, you need to mark that as a tech debt, saying we won't be able to handle more than, say, X number of users until we go to a different type of database technology. The other kind of thing is to redefine the bug as redefine bugs as a feature, which you also do.
So anybody in the audience has anything to add on tech debts?
On that, what you said earlier about communication, like if a developer, or I think it's not just the leads, but the developers need to be able to think in that level of understanding the business users' problem when also looking at tech debt and so on, right? So to be able to communicate that this particular thing could potentially cause a problem, they would need to have that. And how do we get everybody to that? Would be a question I would ask them.
When you say how do we get everybody to accept that they're well, if it's a junior developer, it's going to be a bit hard. But I think the more senior guys will need to preemptively ask certain questions from the product owner, because product owners are not thinking in terms of number of users, number of failure points, those things they don't think. So it's our job to ask them, how many times do you expect users to use this on a typical day? And if it's a list kind of thing, how many items do you think there'll be in this list? Or stuff like how bad it is for the customer if this feature fails. Certain features, if it fails, nothing much, he can come back later. Certain features, if it fails, there's a customer sitting in front of you and you can't do your business. So those they won't explain. You have to ask, and based on that, you need to make your technology choices. And once you made your technology choices, you take it to the product owner and says, okay, to build this, I need 6 months. He says, no, we can't wait 6 months. Then you come back and say, okay, we'll do it in 4 months. But here are the tech debts we are going to incur. Here's the risk. You want to go ahead or not? And that's another aspect where communication is important, because if you're going ahead with tech debt, get the product owner's approval. Otherwise, you are going to be in hot water, because they'll say, you never told me, what is this? Show it to them in language that they can understand. Ask. It's like a disclaimer. When you're going to surgery, you get this thing. No, either you come out well or here are the risks. You need to make them understand the risks and say yes or no. Give them that decision. I don't know whether that answered the question.
Right. So I think we are also almost at the end of the questions. We have like one last philosophical question for Dishan. Right. So So as a design philosophy, right? Can you define the importance of focusing on abstraction rather than details, on details?
So yeah, talking about abstractions, so in software engineering, there are abstractions at different levels. For instance, at class levels, at component levels, but I really want to focus on higher level abstractions like entire services, for instance. So whenever you're working on something, let's say you are writing a new microservice for user configuration management. So at the end of the day, after you write it, when you write it, the actual developer works is like you write a bunch of endpoints. You have a bunch of controllers, whatever. So, but you see it as a set of requests. You see the details. You work with the details. So my point that I want to highlight here is that you should always keep in mind the abstract picture, the abstraction level that you have there, which is like that service, it's not just a collection of endpoints, it's something more. It has a certain set of characteristics, and that's why you've bundled up it as a microservice and deployed. So often when you focus on the details, you might be tempted to add one or two other endpoints there which might necessarily break that encapsulation or the abstraction, because it's easier to do that. But when you are writing software which should be maintained for many years to come, it's really important to identify that and distinguish what you should have there and what's not. That's just an example. So I mean, things like that. So I've seen especially junior developers not picking that up, because what they work on is say one or two endpoints in that service, but they need to always keep in mind what actually they're building. They're building a service which is its own entity, its own abstraction. So that's much.
Yeah, so if I add a little bit as an example, so don't take it as I'm going to take an example from our domain. So don't personalize it. I don't know whether it's the way that is, but just an example. So let's say we have a payment, right? So payment API, right? Which is doing millions of transactions per day, and which might be doing thousands of transactions per second, right? So we have an interface which is responsible to do a lot more things or faster way. So to the same API or to the same microservice, if we go and add API to define a payment type, right? Would that make sense? Does it have the same abstraction? Or payment type definition might be an admin's job, right? Or you set up only once, right? So is it something like that you are talking, Dishan?
So it could be that, but to properly answer that, you'll have to have a lot more context. Is there a service capable of handling that separately? Then that's probably the case. In most cases, you might be tempted to say there's something like that. Maybe you want to move it to a new service, and when you do, you'll see that there might be several other APIs, which some other endpoints that you might be able to group to something else. So I mean, in the end, it depends a lot on the context there. So I think there are some very good resources about how Netflix have done it. They have over 500 microservices doing that, and how they contextualize each service. But it's almost always based on the given context. So it could be something. Yeah.
Right. So any other questions from the panel? So we are at the end. So, so I hope everybody will now go and look up what is Pragmatic Programmer. This is just like a pinch of it, right? So it's an entire book. So just search, you will find the PDFs as well of the older version. But I recommend you to get the new book. Or we also will try to get some books probably.
Thinking of getting a few copies down.
Yeah, so we'll probably get some copies to the office as well, so you all might be able to refer them. Right, so I would like to thank the panel, because without them I couldn't have organized this. So they rendered a lot of support. So I would like you all to give a big hand of applause. Right. So thank you everybody for the participation. I hope we managed to inculcate something into your minds and for you to go and refer. Thanks.